Hello, good morning, everyone. Is my screen
Morning.
visible?
Morning. Yeah.
Okay. We have 21 members in the call, so I wanted to have a quick introduction. Maybe we could do that from next class. So what we can do, just type in the chat your name, your experience, and what is your expectation out of this class. Yeah, so just type the details in the chat so that we can finish and then get started. Hi, Gokul. You can also type in your experience and what is your expectation. Just name, experience, your expectation. Sahaj Gupta, 3 years of experience and expectation is to learn Kubernetes and Terraform. Good. Vikas Chaudhary, platform engineer working for a product-based fintech company, 4 years of experience. Okay, good, great. 8 years in DevOps and case in, okay. Good. We have experienced people as well in the call, which is good. Yeah, Manish, 3 years of experience, software testing, need to change domain to DevOps engineer. Yeah, I think right candidate. Local 16 years Windows admin, and you want to become a DevOps architect with latest domain knowledge. Good. Yeah. Indrajit, with 2 years of experience in HPE, expectation to get strong and understanding of DevOps and related techs. Yeah. Ashwin, 5 years, expecting the Kubernetes in-depth and hands-on experience. Bang on, yeah. Sheikh Rafiq, 3 years, learn K8s and Terraform. Ulika, 2 years, Kubernetes Terraform with debugging, good. Atla, 4 years of experience, infra support, learn K8s with Terraform and with automation, good. Swarna, 4 years of experience with debugging and troubleshooting enterprise applications and Terraform issues, good. Roshan, 7+ years of IT experience, learn and get into DevOps, great. We know 5 years of experience, you're into application support, expectations to learn, yeah, obstacles. 3 years, Jinesh, good knowledge in DevOps, good. Haribonesh, 7 years of cloud engineer. Okay. And the expectation is all want to get into DevOps and learn excel in Kubernetes and Terraform. So which is the expectation. Priyanshu, 3 years. It's internal from very basic to advanced, CNI, container, D, OCI, and then etcd in depth. Okay. Majida, 4 years into DevOps. It's in depth to land a better job. Great. Yeah. I got your expectation. So most of them are similar, which is good. Then let's get started. Yep. So this about this Bootstrap program. So we are mainly focusing on Kubernetes and infrastructure mastery in this 10 weeks of program. And then my target audience would be, I think you're all there already. So DevOps, platform engineers, cloud engineers, SRE, system admin and developers, and then who are preparing for CNCF certifications, plus whoever wants to land into a DevOps profile from different stream. So those are my target audience for this course. Yeah. And about me, So this is my profile. So I'm Lavanya. I'm an instructor for this masterclass. So I have 15 years of experience into cloud, DevOps, SRE, and platform engineering for the last 10 years. Yeah. So now I am a solopreneur. My current client is Volvo Cars, where I am associated with my client for more than 6 years. Yeah. So I'm a Golden Cube astronaut. If you know what that means, I have completed all the Kubernetes related certification last year. So I'm the first one to get it in the Asian continent, first woman to get it in the Asian continent. So which makes myself a certified instructor. So that's my Credly profile. This is my Credly profile. And if you're not in connect with me in the LinkedIn, you can scan this QR code, just send a request so that we can get in connected in future. So that's my CNCF profile, where I'm the Golden Cube astronaut. So you can find me there. And I'm also actively participating in Kubernetes related events. So you can catch me there. Yeah, we can have a face-to-face whenever there is an event. So that's about me. So the approach that I'm going to use for this Bootstrap camp is every class should have a lab session. At least 50% time should be allocated for labs. And then I want every one of you to have the system ready with all the prerequisites mentioned so that we can use the lab timing as efficiently as possible. And then, yeah, first we'll get into the context and then understand and implement and troubleshoot and debug and deploy. Yeah. So that's the approach of this session. And we will dig into the real world scenarios and always think about the production scenarios. Yeah. Since I am into the production development for more than 10 years into Kubernetes, so I think I can get you to understand at least what the production environment will look like and how the real-time troubleshooting will happen. So I can get you those details. And so this is not a straight curriculum based session. So I will anyways go through all the 10 weeks agenda now. But if there are any tool requirement that you need that is not covered as part of this curriculum, so we can adjust that and we can spend some time covering that tool in the next class. So if you just tell me in advance, we can prepare for the lab and then we can deep dive into that add-on tools. So that's not straight as per the curriculum as well. Yeah. So every session, I would like to give some questions, and maybe if you are willing, I can call out some names and you can answer the question. Even if you don't know, that's completely fine. So this session is not to make you nervous or something. So if you don't know, we are here to learn that in this class. So that is what our intent is. So maybe I might ask some questions randomly, pointing out names. So if you are interested, you can switch on your camera and then respond to my question. So if you are okay with that, just give me a thumbs up in the chat. Then we can, yeah, good. Anyways, we all have to land in the interview panels. So you have to be ready for that. Good. I think we are all on the same page. Yep, any questions? You can raise your hand if you have any question. We can stop there and there. If you don't understand also, don't let me pass from that slide. We'll stop there and then we can cover that and then we clear the doubts and then proceed forward. So, yeah. I hope you all have a good configuration machine. So this is a prerequisite that has to be installed on your machine. So you should have the Docker desktop installed. And if you are using a Windows machine, you need to have WSL enabled because we need Linux-based terminal to work on. So you need to have WSL enabled for Windows machine. For Mac, you need to work on the terminal. So yeah. The laptop configuration, you should be having at least 16 GB because we are going to set up local lab setup and then debug there. Yeah, pretty much that's it. So we have Kubernetes courses online and other platforms like Udemy, Cloud. So what this is special for? What we are going to get in this course as a special thing? So every class should have at least 15 minutes of Q&A, focusing mainly on mock interview. Yeah, so that will happen every session before and after. So if I'm doing a session today, I might ask question in the next session so that we understand and just prepare for the mock interview based on the session that we have done already. And we are not going to have a repeated session. So whatever we learn today, it has to be the prerequisite for the next session. So we cannot keep repeating the same things again and again. So we have a strict time constraint. So we have 25 hours to cover in this Bootstrap program. So we don't want to spend again and again visiting the same things. So if you have any questions on the concept, we can go through. But I want every one of you to stay focused and have a note with you to write it down, and then I can give some projects as well. So you can do that before coming to the next session. So yeah, focusing more on lab, and we can do that live troubleshooting. If you are facing any issues, you can go ahead and share your machine. So we do the troubleshooting then and there. So yeah, that's it. I hope everyone is clear. You can't. Okay. Do you see my screen now? So I'm into the tools page.
Yeah, we can see, Lavanya.
Okay, fine then. So as part of this masterclass, we are going to cover not only Kubernetes and the Kubernetes ecosystem. So where we'll focus on all these tools. So you just can't learn Kubernetes and then you just can't be a Kubernetes expert. So you need to understand and learn all the relevant tools to say that you have really worked on Kubernetes. So for example, if you are into Kubernetes, you just can't nowadays everyone is into managed Kubernetes. You can't just say that you learned Kubernetes, vanilla Kubernetes, and then you worked on it without understanding any tools. So I'm going to take you to a demo with Kubernetes and also some of the cloud Kubernetes environment like Azure Kubernetes or AWS Kubernetes. So whatever we can do best possible, we can explore the managed Kubernetes as well. And then, yeah, of course, the intent is to understand more on infrastructure as a code, especially Terraform. And then we can understand what is Helm and customization as part of package management. And then for GitOps, we are going to explore the Argo CD tool, which is more widely adopted CNCF tool. And for Ingress controller, we are going to go through Nginx Gateway API, Istio, Nginx being deprecated. So it will be deprecated in 2026. So we have to learn other equivalent tool. So we can go through the Gateway API and the famous Ingress controller is Istio. So we are going to cover that as well. And CNIs, what is the importance of CNIs? So CNIs are building blocks of Kubernetes. So you cannot learn Kubernetes without understanding the CNIs. So we will learn at least 2 CNIs and what is the difference between each of these two and what is famous, what's been widely adopted, what's been widely used across the production environment. So that's on the CNI course that we will cover. And the major, so once you learn Kubernetes, the next thing you have to know is Istio. So without Istio, nobody will realize that you have really worked on Kubernetes environment at all. So you need to understand what service mesh, what. So we are going to learn Istio and other competitive tool like Linkerd, but this course I am going to cover Istio. So we will cover Istio as part of service mesh, and for policy as a code, definitely you need to focus on security as well. So we will understand PSA as well as Kyberno as an external tool. So apart from Kubernetes, we are going to learn all these tools. And for scaling, Kubernetes provides inbuilt scaling. So we will learn additional tool called CKAD for event-based scaling. So all these are apart from your Kubernetes. And for observability, we are going to learn Prometheus and Grafana and other open source CFK stacks to monitor, especially for monitoring and observability. So this is the tool that we will cover as part of this masterclass. And of course, for backup and restore, we will use the Velero open source and security tree scanning. So these are the tools that we are going to cover as part of this program. And then, yeah. I would like to move to the final slide just to show what we will learn at the end of the masterclass. So this is how your Kubernetes cluster setup will look like. So you will get deep dive on Terraform, Kubernetes, Istio, Prometheus and Grafana, Cilium, Ingress controller, API gateway, yeah, and Nginx, and for GitOps, Argo series. So this is the ecosystem that will look like at the end of this session. So this is the expectation. But if you need few more tools to be covered, we can adopt that in some of the session wherever time permits. Yeah. Any questions?
Couple of them they have mentioned regarding is there any cost optimization like Kubernetes short? And Sharna is asking about Helm.
Okay. So you want to understand cube cost. Yeah, why not? We can add that. Helm, yes. We have the Helm covered in the slide. Are my slides not changing? Let me see. I just added your ask. So we can explore cube cost or some other tools. We have other tools like Apptio. So whichever is possible, we can cover as part of open source. Yeah. And Helm, we are covering it in the package manager session.
Ivanya, so Rakesh here. So just wanted to understand, like, what is the prerequisite of this bootcamp?
In terms of knowledge into DevOps, is that what you're asking?
Yeah, so for example, I have basic understanding of Docker and Kubernetes, and I have learned from YouTube. And I mean, I don't have that much real-time knowledge. So in that term, I'm asking, like, am I eligible for this bootcamp, or how we are going to take this?
Yes, of course, you are eligible. So the prerequisite is you need to have a little bit of Docker understanding. If you don't know a bit of Kubernetes, that is fine. So we are going to do that in this session. So if you know Docker and a little bit of Linux, if you don't know also, you can get your hands by looking at some basic YouTube sessions. So that should be fine. So basics of Docker and Linux should be enough for this course. Yeah. So it is going to be we are going to learn from the scratch. So we are going to start building a local cluster, and from then and there we are going to cover all these tools. So it does not require knowledge on any of these tools. That's what I'm saying.
All right, thank you.
Okay. Let me see the chat if there are more. Okay, then let's move on to the agenda further. So do you see my slide now?
Yeah, so we can see page number 7. That's correct.
Week 1, Kubernetes Foundation and Environment Setup.
No, we can see this cloud native mastery tools that power production. I mean, I can see that only.
Yes, it's not changing.
Yes, correct. It is cloud native mastery.
Just a minute, let me figure that out.
Lavanya ही है, देखो यहाँ। Lavanya ही इसका नाम।
Yeah, now we can see week 1. Yeah.
Okay. Mm-hmm. Yeah, do you see that now?
Yeah, week 1. Yeah.
Yeah, we can see week 1. If you could just maximize this page, Lavanya.
Yeah, good. So week 1, which is today, we are going to understand the Kubernetes foundation and environment setup. So that's the agenda for today. So we are going to understand what is container versus container orchestration. And we'll understand the Kubernetes architecture. And then why do we need container orchestration at all? So what is the advantage? And we'll debunk the challenge as well, because we need to understand the challenge of Kubernetes. Then only we can excel in that, or at least try to get the most out of it. Yeah. And of course, we have to focus on the lab. So for lab, we will have to install Docker desktop, KubeCtl, Helm, Terraform, so which we are going to do today. And then we will set up a kind or Minikube cluster and few tools to interact with the Kubernetes cluster. So that is the agenda for today. And yeah, of course, for the Terraform, we'll understand why we have Terraform as infrastructure as a code, why not other tools, and real world industry, how does it look like with respect to Terraform, and is it going to replace anytime soon, or how the next 2-3 years, what is the tool that is going to dominate, and what is the tool that we're dominating for a few years now. So, and again, Terraform foundation and setup that we are planning to understand in this session. So that's on the week 1 agenda. And for the week 2, so we will go through the Terraform ecosystem next week only. Do you see week 2 slide now?
No.
Why it is happening there?
Or you can send the slide here so that we can, download and we can, view from there, if that works.
Yeah, that should work.
Click on share, na. Click on share.
Yeah, I think we have shared it already. Right? Isn't it?
Just copy the link. Just click on share, and I will tell you how. Click on share. Go there. Okay. Copy link. Put it in the chat box.
Okay. Thank you. Can you all open that? Sorry about that.
Yes. Okay.
Yeah, it's fine loading now. Thank you.
Okay. So just if you don't see my screen, just check the week 2 slide. So in the week 2, we are going to cover the Terraform ecosystem. So where we are going to cover the basics of HCL templates and what is Terraform resources, variables, and data sources. And then we will cover the providers as well, how to connect to the different providers that are available. And then what is the backend, secret management, dependency. These are the main Terraform ecosystem that we will cover next week. Moving on to the 11th slide, week 2 again. So each and every week we will cover both Terraform and Kubernetes. So one day we'll primarily focus on Terraform, or we can mix both of them. So however best we can do, we can try covering both of them in those 2 sessions. So again, we will cover on week 2, we'll cover the Kubernetes core objects like pods, replica sets, deployments, and stateful set, daemon sets. What's the difference between these and when to use what? So what's the advantage of using which? So those things we'll cover. And of course, namespace, labels, services, config maps. So if you don't know, if you have not heard any of these terms, don't worry, we are going to look at it in the week 2. And then going to week 3, we will cover the Kubernetes package management. So we cannot understand Kubernetes without understanding its ecosystem and tools related to it. So we have to use Helm. So we need to be master in Helm debugging, challenges, and onboarding with Helm. And what's the difference between customize and Helm? So we are going to look at the templates of it, how we are going to utilize the values file in the Helm charts and dependency charts. How do we upgrade Helms, roll back and install? So all those things we are going to see in week 3. And again, week 3 will also cover the Terraform advanced concepts like remote storage, state locking, modules. Those are very widely used in the production setup, without which you cannot learn Terraform in a production grade environment. And of course, we'll understand workspaces and data sources and lifecycle management in Terraform. So this we are going to learn in week 3. And in week 4, here comes the Kubernetes advantages part, where we are going to understand what is scaling and self-healing, what does that resilience mean, and this is a platform for custom operators as well. So it's not only for the tools that which I'm telling today. There might be a lot of other tools that will be widely used across. So we'll understand different tools, and then we will explore some of them. So what are the tools? So I'm going to target one tool for one area. So you will have 10 such tools. So if you understand one, the concept behind will be the same, and it will be just the competing tool that will be used. So that's it. So we'll understand them in the week 4. And again, on the week 4, we'll dig into Terraform deep dive. How do we apply? How do we validate? How do we create the resources with Terraform? Here is what your real-time Terraform work will fall in picture. So yeah, so we'll understand the Terraform workflows, backends, provider and authentication. How does it work? And we of course we have to use resource variable outputs, data blocks, all those things, and environment variables. How we can use the environment variables and secret handling and state files. Yeah, so that will cover in the 4th week. And 5th week, we'll cover the building blocks like modules and how to use the modules, and what is the code reusability in Terraform with respect to modules and functions, how best we can use functions to do repeated tasks, stuff like that, with lab exercise on all these areas. And we'll understand the modular design, how a production environment will look like. Yeah. Moving on to the week 5. We will, on the Kubernetes, we will understand the scheduling, scaling, and storage part here. So we'll get to know what's Kubernetes scheduler, node selectors, affinity and anti-affinity, change and toleration. So these are the concepts that we are going to look at week 5. So maybe these terminologies are new for now, but we are going to explore. So 6th week, we are going to look at the advanced resource management. I'm not going to go through each and every detail since it will be too much for now. So we'll just explore what we are going to do as part of this 10-week program. In week 6, your cluster upgrades, cluster management, day-to-day operations will fall in picture. And week 7, so now we are going to combine both Kubernetes management using Terraform. So we'll create the Kubernetes cluster with Terraform and Kubernetes namespaces with Terraform. So how they get into a clash. So we have to use both of them in our environment. So we will use Terraform in Kubernetes cluster. So week 7, from week 7, you will see different tools getting introduced in our sessions. So it will be Argo CD, where Argo CD will use Git as a source of truth. And if you see, Argo CD is widely adopted in CNCF, and it is a popular tool in GitOps world for Kubernetes. So how do we bootstrap with Argo CD, and how we do the rollbacks, upgrades, and how we have to onboard an application using Argo CD. All those things we are going to cover in this week. And week 8 will be the observability and monitoring. Yeah, so without observability and monitoring, we don't know what's happening in the cluster. So we are going to debunk in week 8. Possibly we'll cover the FinOps tools here, like KubeCost or Aptio. Oh, yeah, so we can try to cover them, as some of you have requested for it. And week 8, we'll understand the challenges in Terraform. So I'll give you real-time scenarios where we will face the challenges. I want you to come up with a solution for that challenge by doing some project from your machine. So yeah. The week 9 will be the Kubernetes security and access control. So we'll understand how security and access is being provisioned in Kubernetes. We will understand the role binding. So these are all the Kubernetes related concepts that we will cover, and also authentication with respect to OIDC. Week 9 will cover Kubernetes security. So there are 2 types of security. So inbuilt security we will cover, and we will also cover security with respect to some other tools like Kyverno for policy and Trivi for image scannings. And week 10 will cover Istio, a service mesh. So why is the importance of service mesh and Istio architecture, traffic management, security, observability, reliance. So yeah, so all these will cover in week 10. And final ecosystem, as I have already shown you, so it will look like this. So you will not only understand the Kubernetes cluster, you will get to know the entire ecosystems which are required to run a production cluster. So these tools we will cover. Yeah, possibly I will also give you some details on how a production cluster will look like, and also what you have to learn further apart from this course. So I can also give you some details so you can do it yourself, the rest of the stuffs, and then I just show you the path. Yeah. So that's about the agenda. Any questions, or if you want me to add anything, just let me know. No, we are not covering the CI tool because the course is mainly focusing on Terraform and the Kubernetes. Yeah. Yes or no? I hope that answers your question. Yeah. Any more questions? So this is not primarily for AI agents, because if you need to add AI agents, first we need to understand the Kubernetes ecosystem. So you need to understand all the tools. So you cannot get started with Gen AI. So as I understood from the expectations that we have everyone, so it's for getting into the Kubernetes world, not into the AI. So first understand in and out of the Kubernetes tools, and then we can work on another, yeah, maybe another course for Gen AI and AI agent. It's not going to be covered in this session. Did that answer, Himanshu?
Like I'm high level. I'm just looking for how to like use like Claude or this kind of tool for like working on Kubernetes or Terraform or that, not specific for Gen AI, how to deploy other things specific for this setup.
Okay, I can give you some details on how to integrate them. but we are not going to have a hands-on lab on how to build them and all, but I will give you some details. Definitely, yes.
Okay, thank you.
Okay. Carpenter for cluster auto scaling. Good. Yes, why not? I am planning to give a demo on AKS cluster in the upcoming course. So we'll try to explore the carpenter. It's not a big deal. Yeah, I think questions are bang on. So Swarna, yes, we can cover the carpenter. But just let me know during our scaling class. I will right away add your expectation somewhere here so that we don't miss. Okay, yeah. So we cannot cover all three clouds. So I can show you how it is deployed in one of the cloud, be it Azure or AWS. It will be same across all the clouds. So if you have a GKA account, you can do that yourself. Yeah. Hope that answers, right, Sheikh. Yeah. Good. Any more questions? So I'll wait for a minute. Yes, networking, we are covering the CNI. We are covering Cilium, Calico. So it will be covered. So we are going to cover all the topics with respect to Kubernetes and as well as few tools to manage the Kubernetes cluster. So it's not, so you cannot just learn Kubernetes and say that you are a master in Kubernetes. So you need to know in and around of the tools which is being used for a different purpose. So we will cover rest of them as well. Yes, reference documents. I will give you more details if you want to explore further. Okay, I think we are good to start for today, I guess. Give me a minute. I'll pull up the slide for this week. Just give me a thumbs up if you see the slide. Speak one slide.
Yes. Yeah.
Okay. So
That's fine now.
let's get started for today. So first we are going to cover the container orchestration. So shall we start or do we need a break?
No, we can start now. We can start now. All people are energetic, full on weekends.
Okay, that's good. So let's understand what is container. Can someone give me an answer if you already know? You can
Container.
Yeah.
Yeah. So container is a package which will contain all the libraries, code, application code, and its dependencies. Where if we run that package, we can create a container out of it. So basically, it's a package with all these configuration.
Right. So exactly what you said is correct. Just adding more details. So container is an independent, consider that as an independent virtual machine. So your application will not consume your entire virtual machine. So it will be a small part of it. It has all the dependencies packaged to it, libraries packaged to it, and then it runs on top of the container engine. So for example, if you are running a Docker, then it runs on top of the Docker engine. So it is not going to run on your, consume your entire virtual machine's memory or CPU. So it is going to consume a part of it. And then in a virtual machine, you can consider, you can host multiple containers parallelly. So container is just a standalone application that runs on a virtual machine. So previously in the traditional approach, if you see, initially a single virtual machine is hosted with an application. So a different set of application, consider that there will be a lot of VMs to manage in the traditional approach. So then came the container. So you in a single virtual machine, you can host multiple containers. So then comes, so now we have the containers, but what the problem is, so you cannot host hundreds and thousands of container onto a virtual machine, and you cannot scale if there is a load. So big billion day or for any events, so you will have a lot of loads. So your container cannot scale automatically. So we had a few challenges. So to address all the challenges, there come in the Kubernetes. And so not only the Kubernetes, it's called container orchestration, and Kubernetes is one such tool to cover container orchestration. So there are other tools like OpenShift. So it is also running on top of Kubernetes. But if you understand Kubernetes, then you can still work on OpenShift. So those are few competing tools. And we had a Docker Swarm initially, but that's not widely used. So Kubernetes is the one that is being widely used. And then if you look at the market, so these are the tools that are widely used. First is Kubernetes. So now, not only the vanilla Kubernetes, there are different flavors of EKS, AKS, GKE, all these tools, and cloud-specific managed Kubernetes are having higher market as compared to the vanilla Kubernetes cluster. The Docker Swarm is not widely used, and Nomad is getting popular even now in the recent days. So, but for all these, Kubernetes will be the common, and then all the concepts that we are going to understand as part of this course, it remains common for all of them. Any questions? Yeah, just unmute yourself and raise your question if you have anything.
Yeah, I have a question. So in self-managed Kubernetes, like what are the tools? Like for example, Mirantis is there. So what other tools are there?
For
Self-managed, like Mirantis is there, right?
Mirantis is there.
So
there
what
are
are other tools?
Yes, we have COPS to manage the self-managed cluster, and on with the COPS you use KubeADM to configure the cluster.
So, like you will teach self-manage also, or just like manage it?
Both of them. So
Okay.
for local, we'll explore the local Kubernetes cluster. So it's not a managed one. So we would use a kind or Minikube, and let's see if we can procure some VMs and then configure KubeADM to configure the self-managed cluster. So we can do that in one of our sessions.
So my question is like there is a master cluster is there. So master node is there. So for master node, it should be there should be 3 master nodes for handling for any failover.
Yes, that will cover it in the high availability. Yes.
Okay.
So I think your questions are mainly related to the architecture, how it would be, right? So let's
Architecture
move
plus
on
tool,
further.
ma'am.
Yes, we can cover them. No worries. So moving on to further on the container orchestration. So now we understood what is the problem with the containers. Then why do we need container orchestration? So you have a single container and then you run your application onto that container, expose it to the port and done. That's it, right? So now think it as a bigger picture. Like you have 20 microservices for a single application and suddenly traffic arises. So you need at least 3 to 4 instances of the same application, right? And then for that, you need to configure the application from the scratch. So since it is a Docker, you need to configure your Docker file, and then you have to again do the Docker run and then expose the port and make your application up. And then, yeah, so during the scale, you need to do all these things either manually or using some automation. And then if a single node crashes, then your one instance of your application will be down. So until you go and fix it manually, it will still be down, right? So same as in if your machine, virtual machine that's hosting your containers, if that goes down, then you lose your application. So that is one of the challenge that we run with the containers. So you definitely need a zero downtime deployments, right? In that case, so that cannot be achieved with the with just containers. So we need the smart tools to manage it for yourself. So you don't have to do a lot of manual stuffs. So that there comes in the Kubernetes. So without container orchestration, you cannot automatically scale your setup. And then if a node goes down, if a container goes down, it cannot spin on its own. It cannot come back on its own without you doing any troubleshooting. So it does the self-healing. It does the self-healing, but Kubernetes does the self-healing for you. If something goes down, it has a capability to bring it down after a few seconds. So there are a lot of intelligence that adds the Kubernetes more resilient and then more popular. So there are a lot of advantages like scalings and self-healings. So it can do the automated work for you. So you don't have to do things when something goes down, and then you don't have anybody to monitor at 2 a.m. if that something goes wrong. So, and for example, if you have multiple instances of the application has to be load balanced. So you cannot do that in the container without making a complicated setup and without someone doing that for you. So, but by default, Kubernetes provides the load balancing capability as well. And then it is hard to manage networking between those containers, right? So Kubernetes provides networking capability, and then we will explore the networking tools, right? Yeah. So, and then if there are any rolling of updates, Kubernetes provide automatic rolling. So you don't have to go and stop the upgrades and then just without any downtime, it does the automatic rolling of updates for you. So that's one of the greatest advantage of using the container orchestration and resource wastage. So you configure what you need. So CPU request limits, everything you will configure in every single application. So which will, so you know how much it is going to use. If there are a lot of loads, maybe you can increase it or you can utilize the scaling capabilities. So there are HPAs and VPAs that are in place. So that does automatic scaling for you. You don't have to do all the manual works for you, right? And then since Kubernetes is a platform, so platform means it can host all other ecosystem tools like your GitOps tools, your container registries like Harbors, and then you can host the certificate management tools as well, cert managers, external DNS to automatically assign certificates for your domains. So all the tools are still there. You can host them, and if there are no such tools that is solving your problem, you can build your own operator. So you can build your own operator and then host it in Kubernetes, and then you go with that tool and you can just consume it. So it's just a platform that provides unified control plane where you can host hell a lot of tools and then make use of it. So let's dig into the Kubernetes architecture. So Kubernetes architecture is a master and slave architecture. So let me pull up a slide and then I'll show you. So basically Kubernetes is mainly, I will still think that as an ocean. So that's why all the analogies of explaining this master and worker nodes are in with the ship related concepts that is being used. So that's why it is used with the ship analogy everywhere. So if you go and see a YouTube video to understand what is Kubernetes, they will start with the ship analogy. So that we are going to use the same to understand the master components. So this is how a master will look like. So we are going to cover all of them. And then this is the worker components. Again, we are going to cover each one of them and then have a lab to see how each and every component will work. So without that, what will happen? So we are going to cover the lab today. And then, so let's dig deep into the components. So first, we'll understand a worker node component. So we don't need a master, right? We don't need a master. We need the worker to do all our tasks. So those are the real workers. So they are the enablers. So worker node is nothing but a virtual machine, okay? Virtual machine where all your containers are hosted. So if you see, this is one of the worker node, and then it has lot of containers. Each and every container is an application, okay? So if there can be lot. So if you see the colors, there can be repeated. There can be different set of application posted onto it. So if one goes down, there is always another one running to serve your traffic. So this is the worker node. So worker node has containers running. So I was talking about the containers, right? These worker nodes run those containers. So these are the real enablers. So this is one of the worker component. So which does actual work for you. So let's see what is the master component. So master component, so usually how master component will be said, they will use control plane as a reference everywhere. So master, control plane, all are meaning the same. Worker nodes and then data plane, these are all meaning the same. So sometimes people will just say master component and control plane component, both implies the same. So master, as it is a master, it is not going to do all the work related jobs. Like it is not going to host your container onto it. So its work is to tell the worker node to schedule the pods, tell the worker nodes to do this schedule. So we have a new job that is assigned. So you do that job. So it's mainly doing the controller work. Control, it just controls it. So it plans, it schedules, it manages, and it monitors if it is being scheduled or not. For example, if a new container request is coming, for example, if you are deploying a new application, so at the end of the day, it is a pod, and then pod is the smallest unit of your application where it has containers running in it. So you consider container as your pod. So who is managing those? Who? So where it has to be scheduled, all these informations master will give. So there are a lot of components in the master. One of the component is the scheduler. So if you see, what does a scheduler do? From the name itself, it schedules pods onto the right nodes. So consider scheduler as your ship cranes. So you have the master, you have the worker, but to place the master onto the right node, so you have to check which node has space. So you have a lot of ships, right? So you have to place your container in the right ship. For example, if your ship is already loaded, if your cargo ship, which is a worker node, it's already loaded, right? If it is loaded, you cannot put more load onto it and then break it. So you cannot do that. So scheduler, which is the ship crane, it will check which node has a free space, which can accommodate the container. So for example, if you have 4-node cluster and your 2 nodes are already with high utilization and 2 nodes are free, the ship crane, which is the cube scheduler, it decides where it has to place that container. So your container, it will be placed onto the 3rd or 4th node. So based on it, just the algorithm, which is the best possible place to place them. So then it places onto the right node so that it will be evenly distributed. So now I'm going to ask you a question. So what happens if a scheduler is down in your infrastructure? Can someone answer? Just unmute yourself and answer. Yeah, it's fine. If you give a wrong answer, that's completely fine.
Pod will not schedule on the node.
Okay.
So how work, right?
Right. So what will happen to the existing pods?
It will not schedule on the any node. So it will be on the not useful, right? These pods are not useful.
Yes, you are right. But what will happen to the existing pods? Any guess?
It
So
will keep running.
Yeah, existing pods will keep on running, whereas the new pods will not get scheduled to any of the new nodes since the scheduler is done.
Okay. Your name?
Sucharita.
Sharita, you are right. Your answer is bang on. So what happens if a cube scheduler is down? So all your existing pod will still be there, but not the new pods. For example, if I am creating a new deployment, new application I'm creating, that will not work. But existing pods will continue to work. So today I have loaded my ships with all the containers, right? All the containers in the sense it is pod. So container pod, I can use it as exchangeably, but for now the context is same. So if you are loading the container today and then after some time your crane is not working, your ship crane is not working, which means your cube scheduler pod is down, then you cannot load the new pods only. All your existing pod will still be loaded, your cluster will still be up and running. So you get the point, right? So the existing application will still run, it only impacts the new application. Clear with the scheduler? Yep. And Kubernetes provides inbuilt scheduler, and also you can create custom schedulers. So you can add a few more schedulers like ship cranes, which to do the job better. So you can have a custom scheduler as well, that we will see. And then, so we are good with scheduler. And we know what happens if the cube scheduler is down. So let's move on to the next master component. So this is the second master component, etcd. etcd means the database. It is the database. So cargo data management, consider that as a cargo data management. So without the database, the Kubernetes does not know what is where. So if your etcd is down, if your database is down, then your Kubernetes cluster will be down. So, but if your other component like scheduler is down, your cluster will not be down. So this is the data management, right? So without the data, it cannot work. So this is one of the crucial component in the Kubernetes cluster. This goes down, then your cluster will be down. It will not be accessible. So it is essential that you need to have a better backup and restore mechanism for etcd database. So this is, so we'll look into it more, like how it will be. So it is a key store database, and then all the data will be in terms of keys and value pairs will be stored. So the entire Kubernetes itself, we will have YAML based deployments. So similarly, this is also a key store. All the deployment, everything you deploy into a cluster, it will be stored in the etcd database. So you got to know the picture, right? So if the etcd is down, your cluster will be down and it will not be accessible, and your application will be down. All your running application will be down. So that's the impact of etcd. And now moving on to the next component, which is
sorry for interrupting.
yes.
So as we said, we need proper backups of etcd. Are we going to
Yes.
cover Velero also for that?
Yes, we are going to cover Velero. It is there in the slide. Yeah. So Velero is widely used backup and restore tool. So we will cover Velero tool.
Okay.
Okay. So next comes another master component, which is API server. So think that as a control tower. Okay. So you will see all these analogies everywhere. Okay, we are just understanding the architecture with the same analogy. We are not inventing something new. So just understand what is there. So API server is the control tower. So without the control tower, there will not be any directions, right? So Kube API server is your control tower. So without the control tower, your cluster will still be down. So all your worker nodes will access your master node through API server. So each and every component will access this API server. This is the brain or heart, whatever you can think. That's the major component in the master. So if your Kube API server is down, it can none of your worker nodes will be able to survive, and even your master nodes cannot connect to the Kube API server. Then your cluster will be down. So that's the impact of API server. So if your API server is down, what will happen? Can someone answer?
Yeah, of course, it causes business outage.
Yes, your cluster will be down. Your API is down, all your application will be down. Entire cluster will not be responding. So yeah. And then I also have one more component, which is the controller. So there are lot of controllers in the master. So usually in the master component, they just say a single controller, but within the Kubernetes ecosystem, there are different types of controller. For example, if you have a deployment, it will have a deployment control. I'll tell you what is a deployment in the upcoming slides. But consider there are different controllers. Controllers are nothing but they control that work. For example, deployment means it controls the deployment creation. Replica controller, it manages your number of applications, replicas of your application. So it is for that. And cloud controller, if you are using a managed Kubernetes cluster into any cloud, so that performs cloud related operations like adding a cloud VMs, cloud nodes. So all those things will be done by that respective controller. So controller is one of the master components, which is also crucial. But if a controller is down, your entire Kubernetes cluster is not going to be down, right? Because it cannot perform the scaling. So anyways, we will see that in the lab, what happens if the controller component is down. Yeah. And then let's move on further to the CNIs. What is a CNI? So basically, Kubernetes, by design, it does not comes with a networking solution. So you will have to bring a third-party solution for networking in Kubernetes. But wherein in, if you think OpenShift and all, they will have inbuilt networking solution, but Kubernetes does not. That is not built like that. So there are a lot of other tools that bring in, and for especially for networking in Kubernetes. I think someone asked in the expectation, like, are we covering the networking as well? Yes, we have to cover the networking because that is not comes by design. So we will cover few tools like Cilium, Calico. So these are most popularly used networking solution for Kubernetes. So why do we need a network? So we have a lot of pods, right? Pods. Pods means applications. So how do they communicate with each other? So it has to have some networking in between them, right? So we need to have some solution for having that network, and also each and every pod will have an IP assignment. So how these IPs are assigned. So those are assigned, done by these networking solutions, like whether it has to be assigned from the subnet, or which IP address to be used for a pod, which IP address to be used for services. So pods and services, we'll see if you don't understand, but we need a networking solution. So yeah, we will cover some of them to route traffic, to IP assign, and to have node-to-node communication. So all these are done by CNIs, the container networking interface. So this is for your networking solution in Kubernetes. So we will cover some of them and advantage of using which and which. Yeah. And what is a container runtime? So Docker is a container runtime, right? So what do you think container runtime is? Why do we need container runtime? So to run a container, you need a container runtime. So for in your local machine, you're running a container using a Docker. Docker is your container runtime engine. Okay. But when it comes to Kubernetes, same, you need to have something on the node. So either Docker or other container tools are there. So Docker is deprecated long time back. So Docker is no more container runtime supported. So there are different container runtimes like Containerd, Creo, and a few other container runtimes are there. So this we can choose when we are deploying it, when we are creating a cluster. So we can define which container runtime to use. So these container runtime, they follow a standard. So if they follow that standard, we can use the any container runtime onto your Kubernetes cluster. You can choose which you want, but ideally, if you choose any of these things, the underlying concept will be same. Like it is going to help your application to run. That's it. It is a runtime. So basically, if you have the master component, which is the API server, and then we'll see what is Kubernetes kubelet, and then container runtime is your networking solution, and then the container runtime is your Docker or Containerd or Creo containers, and then that is helping your container to start. So these are the main use of container runtime, is to start your application. Is to run your containers onto the node. So that is the use of it. So without container, if the container runtime, like if you have some problem with this runtime, your container workload will not be scheduled. Okay. Yeah. So we are going to look at the worker node now. So I've already told you what is a worker node, right? Worker node is a cargo ship. So now we are going to see what's kubelet. Kubelet is one of the worker node component. So think that has a ship captain. So you have a lot of small ships, right? So each and every ship needs someone to control it. So without a ship captain, your ship is not going to perform anything, right? He needs to communicate to somebody for checking the direction, or to move into the right direction along with the master. So a ship captain is mainly responsible for making your worker node up. So now I'll ask you, if a kubelet is down, what will happen? if your kubelet is down, what will happen to your worker node? So it will not get any information from master. So the connection will be cut from the master, right? So all your application running in the worker node will be down. So that is one of the major problem. If your kubelet goes down, your application on that node will be down. So for example, if you host the application into multiple replicas onto different worker nodes, it will still survive with another replicas. But this node goes down means application on running on this node will be down, and you will have a downtime if you don't manage your scaling properly. Okay, got it? What's the problem when the kubelet is down? So now let's move on to another component. This is also a worker component, which is kube proxy. Any idea what it could be?
Kube proxy store the IPs of all the pods, new pods created.
Right. So they say it as a crew member, but I would like to take a different analogy here. For example, kube proxy, consider your worker node is created in Chennai. Okay, worker node 1. Your worker node 1 is Bangalore. Okay, but to communicate these two, you need a component, right, to communicate between these two nodes, because all your pods are scheduled in Chennai work node and Bangalore Bangalore machines, right? So you need some sort of communication between these two. So that is your kube proxy. So kube proxy, so the mode of communication is kube proxy, like mode of transport, not communication, transport, be it a train or a flight. So that is a different types of like different ways to connect these nodes, right? So there can be an IP table. So kube proxy, it manages a table where it will have all the details of pods that are stored in this nodes. For example, in Chennai, what are all the places, what are all the buses, transport details, everything will be managed by kube proxy. And same, there will be another kube proxy in Bangalore node. Okay, so how these communicates? So this gets communicated using this kube proxy. And then I told like train, mode of transport is train or a flight. So traditionally there was a usage with kube proxy. Now eBPF concepts and all coming into picture, which makes more advantage of using the eBPF concept, which we will see when covering the Cilium. So which is more advantage of using kube proxy. So just kube proxy, consider that node to node communication, it will manage a database itself. So if kube proxy is down, node to node communication will be down. So the communication will be cut off. So if that cut off, it still will make your application down. So for example, if a kube proxy on that machine is down, then it cannot do any communication. So it does not show that I am hosting this application. It does not do any of that. So if kube proxy is a worker node critical component, if kube proxy goes down, then your application will be down. Same with kubelet. Kubelet goes down, then your application will still be down. Okay, so these two are primarily worker node component which are critical. So if you think of the master component, API server is extremely critical and etcd database is extremely critical, but it can survive a bit of an outage with respect to controller or a scheduler, but not these primary components like etcd and API. Okay, so now we have seen in theory what is API server, scheduler, controller. These are the master components, and how do we connect to this API? So all your communication will go through API server. So you will use certain tools to communicate with the API server. So one such tool is kubectl. So you will use a CLI tool. Today we will during the lab session we will install a kubectl tool to communicate with the kube API server, and there are a lot of other tools as well that we will explore it, okay, during the lab session. So on the whole, your architecture will look like this. So in the master, you will have controller and your API is your control tower, without which you will not get directions where to go. So this is one of the critical component. An etcd database where all your details of your application, your server details, where your how many API server instances are running, all these details will be stored in the etcd. If that goes down, then your application, your cluster itself is down. Consider etcd is down means your infrastructure is down. API server is down, infrastructure is down, controller is down, few part of your application will not work. And again, your scheduler is down, a new pod will not be scheduled. But still there will be an already existing application that will still be running. And what is a container? That's your application that's your application running on to the worker node. So these are the worker node components. Kubelet is the ship captain. So if that is down, it does not get instruction from the API server, like who has to be scheduled where and who is seated where. So that if that details are also not there, then it does not, it is lost. It is lost in the ocean, right? So kubelet is down, your cluster is down. Again, your kube proxy is down, then again your cluster will be down. It does not have a means of communication with other nodes. Other nodes are all, as well as master. So your kube proxy is down, your cluster will still be down. So are we good with the at least understanding what is master, what is worker, and what are the components that are there, and then what is the use of what? Do you get that?
Lavanya, I have a doubt on kubelet. Actually, kubelet. Can you
Kubelet, yeah.
explain kubelet again?
Sure.
Thank you.
Yes. So you have the worker node. Worker node, consider that's a virtual machine, right? So in your virtual machine, you have all the containers scheduled, right? So who gives information like where it has to go?
From API server, it gets the information.
Exactly. So API server, is it visible?
Yes. It is.
So API server is, it received a request, like I have a new application to be deployed, right? And
Yes.
to whom it will tell? Scheduler. Scheduler is the one. I hope you don't mind if I misspell it, right? So API server gives the instruction to scheduler that we have a new application, and then what this scheduler will do, it will, to whom it will go and inform in the worker node. It will tell the kubelet, right?
Okay.
Because this is running in worker node.
Okay.
So this is your worker node component. This is your master.
So then kubelet is the heart of the worker node. Can I relate it something like that?
Yes, that is the heart. You can consider kubelet and kube proxy as heart and brain of the worker node. If kubelet is down, then scheduler will not instruct kubelet, and also this kubelet will in turn respond again to API server. Like, so just consider that there is a mark here. So the kubelet gets instruction from API server that it has to schedule a pod. Scheduler will do the scheduling, identify which worker node is free. And then, for example, this worker node, consider this as worker node 1, this is free, and your new application came in today, and application 1 came in, and then you have to schedule, right? So application 1 is received, and API server informs the scheduler to schedule a pod onto the worker node. So worker 1 is selected. So your kubelet, it will instruct the kubelet to schedule the pods. So if kubelet goes down, your application pod will not be scheduled onto the worker node. And also if kubelet is down, your existing pod information will not be available in API server. So it is one of the important component to schedule and also to report back. So if your worker kubelet is down, it will not get the information and it will not send the information of the running applications as well. So yeah, this your entire application running on this worker load will be down.
So in this picture, ATCD is not come, right?
So etcd, so that's one of the master component. So a new application is there, right? So where those details will be stored? You want. So this is the database. etcd is the database, right? So your new application details will be stored in etcd. So this is just the storage. Okay. All the details are stored as key value pairs in this database. So this is the storage. So, but this is not going to do any of the work in terms of communication. So all the communication, everything will be taken care by rest of the components. So these details will be picked up from the etcd. The API server will instruct scheduler to schedule it onto the kubelet, right? And also one more component, I think I would also add that, which is controller. So what that will do? So the different types of controller I said, right? So now let's look at the replica controller. So replica controller is one of the type of controller. So up to these, it's a master component. What this will do? Manage the replicas. Replicas means instances, or it will have an identical copy of your application. So as the name says, it will manage identical copy of your application. So if the replica controller is down, your identical copy of application will not be, you cannot scale more or you cannot scale down. Scale up or scale down will not work. So this is the importance of controller, and scheduler will go and instruct the kubelet to schedule a pod. Okay, I got a request from Kube API server to schedule a pod onto your node, like worker node 1. So if this is full, then again the scheduler will come into a picture, like it will do an algorithm, like which node has more space and which is underutilized. It will evaluate and then it will give the detail, like go to worker 1 is full, go to worker node, and then again it will go and check kubelet of that worker node, and then it will inform kubelet, and then kubelet will schedule the pod.
So basically, it reports everything to API server and gets information to schedule a pod onto the node.
Correct, exactly. So that's what the ship captain does, right? So it gets an information from master, and then it will tell you go and schedule all here. You go and see it here. So it just inform the worker node that you have to be scheduled here. Yeah. Okay. So this is just a very poor in writing it as picture, but you can imagine yourself like this or just like this. So etcd is your key store database, and your API server is the heart of your master component. API server is the master component which does all the scheduling and controlling works. So these are the master component, and how to access the Kubernetes cluster using some tools. You need to have kubectl or a different tools to access the Kube API server. So for example, if you run any kubectl kubectl commands, it will go and invoke the master and API server, and then it will do all the scheduling stuffs like that. Okay. If we are good, we can move to the lab session today. So here, I want everyone now to install Docker desktop before we get started. Then we will plan to install all these tools. So should we take a break?
Lavanya, actually, I have one doubt. Like when we run the kubectl get pod, okay. So where the request goes first, on the worker node or the master node?
Can you repeat that?
When we run the kubectl get pod command, okay. So when where the request goes first, right, on the worker node or the master node?
So when you do any kubectl command, the request will go to API server, which is
Okay.
the master.
Okay.
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 So any communication that you do with respect to any tools, the starting point is the kube API server. And then if you just enter kubectl get commands, so KPI server will have all the information, and then it will, this is the entry point of all the tools that all the commands that you do, right? So that is going to respond to your queries. So you cannot run a command against a scheduler. So all the, for example, kubectl get pods, and you see your application pod is pending state because it does not have a worker node to schedule. Still, that information will be received from API server, but API server will check with scheduler for scheduling. Okay, but your response will be from the API server. So any kubectl command, it gives a response from the API server. So not, you cannot directly go and call the kubelet and get a response. So you can connect to the worker node, you can execute into the worker node and check the kubelet logs, and you can check the logs of your applications. But you will not execute a kubectl command against controller, against scheduler. So it is always going to be response from the API server. Okay. Yep. Can we dive into the lab? Maybe after taking 5 minutes break, if we are all good. I think I take that as yes.
So do we need to install Docker desktop on Windows laptop, or can we use it on
Yes, yes, yeah. So I want everyone to install Docker desktop before we start the lab session. So now the time is 12:05, 12:04. So we can start at maybe 12:15. I want everyone to install Docker desktop. Will that work?
Yes, thank you.
Okay. Okay, let's meet at 12:15. Yeah. Hello. Right. Can I get a thumbs up? Can we restart? Good. So before moving on to the lab, I want to re-emphasize on the Kubernetes architecture again. Can we go again? Just to brush up what we understood. Okay. So this is us. So if you do any kubectl command or from using any other APIs, it is going to contact your API server. This is your API server. This API server is the heart of your application, heart of your Kubernetes cluster. So basically, this API server connects to your etcd database. So this database has all your infrastructure information stored. So API server is the only component that gets connected to your etcd database. I thought I was sharing my screen. Just a minute.
It's not visible.
Okay, I didn't share my screen. Just a minute. Is it visible now?
Yes, ma'am.
Yeah, okay. So let me restart. So whenever we do any kubectl command or from any other CLIs or from any API, it first reaches the API server. So this is our API server. So this API server connects to the etcd database. So this etcd database is the one that I was talking about. It has all the information about your cluster, about your infrastructure. So each and every single detail will be stored in the etcd database. So API server is the only component that connects to the etcd database. Okay. And this API server is the front end for all sort of communication. So be it you running a kubectl command or be it your worker node interacting with master node. So this is going to be the entry point for all the communication. So this API server also connects with scheduler to check which worker nodes a pod can be scheduled. So the scheduler in turn connects to the API server because API server needs to give the information which application has come and where it has to be scheduled. So the scheduler job is to schedule onto the right worker node. So this again connects to the API server. Okay, and coming to the controller, there are a lot of controllers, I said. So there is an inbuilt kube controller manager, which performs all the controlling operations like managing the number of replicas, managing the nodes, like node controller, replica controller, and custom operator controllers, cloud controllers. There are a lot of controllers, so which performs that specific operation. This controller is again connecting to API server for all the details. So API server is the entry point for all sort of communication. And again, cloud controller manager is one such another controller where it gets connected to the external cloud infrastructure and gets the no details and all. So basically, it performs its respective controller works. Okay. So these are the major components: etcd, scheduler, controller, API server. Yeah. So now you understood what is the master component, right? So let's go to the worker component again. So the API server is the entry point for communication. So API server communicates to the worker node. How it communicates? It communicates through the kubelet. So this is the kubelet that runs on to the worker node. So all the communication that happens to the worker node from master node is through kubelet. So all the kubelets will be connected to the API server. API server is the one that instructs whether any new pod is coming. You have to be scheduled. And then also the kubelet reports back what are the pods that are running onto the node. So it just every few seconds it connects to the API server with all the details. So I have all these pods that are running. So if this worker node goes down, your application is still be surviving from this worker node, right? If there are multiple instances of the pod that is running, it will be served from this worker node. But for that, it needs to send the information, right? So kubelet is the one that is going to send the information and receive the information for scheduling new pods and send the information of the existing pods. So it does a to and fro communication. So all the communication to the worker node will go through from kubelet. Master node communication will be from the API server. Okay. So this is the worker node. In the worker node, I said container runtime. That's your Docker, for example, or container D that runs your pod. And kubeproxy is the one that communicates to other node. So it performs node to node communication and pod to pod communication across these nodes. So this communication is managed by kubeproxy. And these are all the Kubernetes objects. So each and every node will have a different types of applications. Like it can have a deployment set, stateful set, cron job. So everything in finally it gets created as a pod. So pod is the smallest unit of your Kubernetes object. So everything finally will be running as a pod. Pod means it can have one or more containers. So depending on your specific needs, now you can think pod and container as one-to-one relationship. Pod means container. Just think that like that. So there are different types of resources that creates a pod, which is stateful set, deployment set, which we will see that in the next class. Are we good with the Kubernetes architecture? Yeah, any doubts? Let's pause for a minute and take few questions.
So, so as kubeproxy doesn't assign IPs to the pods, what exact job it does? Not like basic routing it does to the pods, but can you give any real-time example?
So how do a kubeproxy will look like? Let me pull up some IP table, then I'll explain you. Okay, just give me a moment. So basically, as you said, it is going to route, but how a kubeproxy will look like, I'll tell you. So basically, your kubeproxy will have an IP table, which will have pod IP, service IP, and on which node it is scheduled. Okay, just a minute. I will pull up some good diagram to showcase that. Okay. So now you're able to see my screen, right? So what does that kubeproxy does? So kubeproxy will have, so basically it does all your networking things. So it will have the keys, like which pods, and then which IP, what is the IP of that pod. So all that will be stored in the IP chain, IP rule chain. So basically it has, for example, I have 3 pods that are there in my node. So in the rule chain, it will have the details of pod 1 and then its IP on, and then node. Again, another consider worker node 2's IP table. So what that will hold? That will hold the IP address at the pod and node. So these are all a simple database that is stored onto that worker node. So basically, to have the communication between these nodes, so we need some databases, right? What I hold, what you hold, so that if there is an application that goes down on my worker node, but I still have to have details of the same application that is running in the other worker node, right? So that is managed by the IP tables, and these IP tables are provided by kubeproxy. So basically, it is considered that as a database for your worker node. So basically, it will have rules, set of rules. IP table is nothing but rules, and then I can maybe during the lab we can see how it looks like. Okay, so we can do some networking commands and then see the real IP tables.
Okay, so
Okay.
if kubeproxy is needed for networking rules and all, what ingress does then? Like, what's the major difference between ingress and kubeproxy?
So your so you have the kubeproxy onto the worker node, so it is not exposed outside of your cluster. So kubeproxy is the component that is running inside the cluster. So it performs the node-to-node communication. So it does not know the outside world. But when it comes to ingress, so what ingress does? Ingress, the main work of ingress is to expose your application outside of your cluster. So you will create a load balancer for that your ingress, and then you will expose the application outside to an URL. But kubeproxy is not going to expose your application onto any external worlds. It's inside your Kubernetes cluster. So it's not going to be helpful in exposing outside. So ingress is the one that exposes your application to the outside world. So you will have an domain, and that domain you will have an IP, and that IP to domain mapping will be done by your ingress, not by your kubeproxy. Kubeproxy is just for internal management of your worker nodes.
Okay, so correct my understanding that, like, so kubeproxy is responsible for setting up rules for assigning IPs and all, whereas ingress is to route traffic like HTTP or HTTPS traffic, like external traffic into the cluster to the pods, right? Is it?
Right. So basically, ingress, as you said, so ingress will have its so you will deploy ingress onto your Kubernetes cluster. Okay. So you will not deploy kubeproxy separately. It comes along with your Kubernetes cluster creation. Okay. So that's an inbuilt component of your cluster. But wherein your ingress is an external component, so you will deploy an ingress controller using Helm chart or kubectl or whatever means. So it will be hosted onto your Kubernetes cluster, and then you have to use it in your application. So you are creating a deployment, right? So then you have to have a service, and then you have to have an ingress component for your application. So without ingress, you cannot expose it outside of your application. So basically, you need a host, HTTP or HTTPS host. So it has to be an HTTPS for your application, right? So it will do all your SSL, HTTP, HTTPS routing, and based on your URL or path-based routing, everything will be done by your ingress. So no routing from the external world will be done by kubeproxy. It is taken care by your ingress controller. Okay. But yes, we will cover the ingress separately. So, okay, so did everyone install Docker desktop? Not already? Hold on. So I have given a link in the chat. Can you open that? So this is the link. So it has week 1 details. And under week 1, you will find a README file. Open that. So you have you all enabled WSL on Windows if you are using a Windows machine? So I'm going to start the Docker onto my machine. See if you are able to run Docker PS command without any errors. Okay. So if you are able to run the Docker command, now go ahead and install the kind CLI. So I have given you the reference link. So based on your OS architecture, you pick up the installation procedure. So if it is a WSL, you just use on Linux command, and if you're using a Mac, just install the kind CLI. Yeah, respective CLI. Yeah, based on your OS architecture, install it.
Lavanya, if you can share the link again.
So you want the kind link?
Yeah.
There you go.
Do we need to install it on our Windows machine or in the WSL?
Yes, you will install it on the WSL.
Okay.
So all the commands that we are going to execute is on the WSL. Just that the Docker desktop will be running, but every command that we are going to do is on the WSL. So let me know if kind is installed. Okay. For those who have done the installation of kind, just move on and install Helm. You open the reference link and then install the Helm against your OS. So on the successful installation, you will see all the Helm related commands if you type as Helm. Okay. That means you have successfully installed. Same goes with the kind.
I have a doubt, like, should we install it on the Windows or in the WS?
In the WSL. So all these are will be installed in the WSL, not on the Windows. So I can try installation.
So the Docker, I have installed it in the Windows. I do it again in the WS also?
No. Docker alone, it will be installed from the Docker desktop Windows. So just that you have to start the Docker. Okay. So I just open the Docker desktop and keep it as in running state so that you can run the Docker commands. So you will in the WSL, you can hit the Docker and you will see the Docker commands.
Understood. Yeah.
Okay. So just Docker desktop is a Windows MSI, you have to install it, and then all the rest of the tools that you will have to install it on the WSL terminal.
Got it. So, and could you share the share this GitHub link also?
Yes, this is shared. Yeah, I can share again and then I'll pin it. Yeah. So kind is installed. Okay. For those of you installed the kind, just go ahead for the rest of the CLI installation. Helm and then kubectl. Do you need any help? If you see any issues, you can just share your machine. Let's see what you are seeing. Just installed Helm.
I am getting path error actually. I don't. Can I share my screen?
Yes, yes, please go ahead and share. So which tool are you installing?
I am installing kind. I think I have run this command on the PowerShell directly.
Okay,
I also got the same error.
just a minute.
I do have a Docker desktop installed
Can you run Docker PS? Docker
Okay.
PS.
on PowerShell. You are saying? Yeah, I do.
Okay, can you, did you enable WSL?
No, no.
Okay.
Shift
I
nine
think
terminal.
open start and search add and add or remove program features. Just go to your start button. Click on the Windows icon. Programs and feature. Search as programs and feature.
I have not installed programs and features.
Turn turn Windows feature on and off. Click on that.
Where?
Turn, maybe you type as turn Windows. Turn. Search as Windows. You turn on Windows features on and off. Click on that. First one.
I have. Should I click here?
Just a minute.
I have not installed WSL.
Yes, you have not installed. So
Yeah.
I'll show you the instruction how to enable it. Yeah. I'll give you the link. You can install WSL.
Which link?
Give you just a minute. So go to your start button. Open this. Yeah. Windows. Search as Windows. Space features. Yes, the first turn Windows feature on and off in the control panel. Yeah, click on that. Click on that.
It is asking for an administrator password. I don't have.
You don't have?
Yeah, this is my office laptop. That's why.
Okay. You need to have a WSL enabled. Anyone else is also facing the same issue?
Can you show me the error? Can you open the terminal? Ma'am, it seems
No.
directly not found, right?
No, I want
Ma'am,
you want to use the WSL terminal, so that's fine. But yeah, you can install kind as an exe in Windows.
Ma'am, actually, if you see, like there is written some dir in your path. So here you need to put the folder name, right? Actually, this folder is not exist. That's why it came.
But make sure that from the next class you try to install WSL, because that looks more, it will help us because it's all related to Linux. So for now you can install the, figure out to install kind as an exe in PowerShell. Just check which location you have downloaded and navigate to that location and run this exe.
Okay.
Ma'am, actually, the kubectl command is working in my system, but I don't know, like, which I installed, like, kind is not working. Kind command is not working, but kubectl command is working.
Okay. What do you see the problem with kind? Can you share?
Same, like path error.
This is a folder issue. You can install the kind.exe in the root folder.
But is there a link like from how we can install kind? Can you share?
Yes,
Okay. So like root user to install. Give a kind.
Just a minute, let me pull up the command and give you guys. Can you try this for the kind installation? For those of you, it's not working. I think this will work for WSL. So for those who of you are using WSL, try this curl command. For Windows, I will check. Windows PowerShell. Yeah. So, do you have Choco chocolate installed? Maybe you can install it using Choco as well. Can you check whether that is installed? Choco.
Yeah, just a second.
Did the kind installation work for WSL? I think Priyanshu, you are the one who raised it, right? Or
Yeah, I have installed.
okay.
And right now I am getting the kind version. I think it is installed. It's installed, right?
Well, just a minute. I'm not.
I have shared
Yes,
my
just
screen.
hit the kind. Just type kind and hit enter. Yep. Yeah, you have installed it. Good then. Can you move
But what is
ahead
it?
and install it?
What? Sorry. What should I do
Can you
next?
install QCL? So now we are just installing all the CLIs required. So we are not doing any installation with kind as of now. So we install all the CLIs, then we begin the local cluster installation. I think we are already past time. So do we have a few more minutes, or do we stop it for today? Just installing all the CLIs. Just let me know if you want me to stop, or we can continue for 10 to 15 minutes and finish the lab for today.
Oh, right now we have to install kubectl and Helm, right?
Yes. Install kubectl and Helm.
Lavanya, this Choco install kind we have to install from PowerShell or from WSL?
So for WSL, you have to install curl and through
okay.
curl command. And for PowerShell, who are using PowerShell, you can install it from Choco. Okay. Yeah, for those of you facing some other issues, you can just take help from ChatGPT or figure out how to install those CLIs. So ideally, this is all straightforward. So just installing the CLI, so that nothing much fancy here.
So WSL is something to operate from Docker desktop, like creation of clusters, etc. WSL is required for that, or we can perform all the tasks through PowerShell itself by installing all the prerequisites.
Yes, if you install all the CLIs in PowerShell, then I think it should it is possible to run the local setup there. So yeah.
Okay.
For those of you install kubectl, Helm, and kind, just move on and install K9S. So I have given a reference link. So K9S is another CLI tool similar to kubectl. So it has a very good UI. It will help us a lot in debugging. So I want you all to install K9S as well.
Actually, what is the difference between K8S, K9S, and the K3S? Like, why there is a number of 8, 9, 3?
Okay. So Kubernetes is the cluster. So why they named 8? Because from K to S, in between characters are 8. So they named it like that, K8S. Okay. And K9S is a CLI tool. Okay. I don't know why they mentioned the 9, but K9S is a CLI tool to interact with your Kubernetes cluster. K9S is a it's similar to your kubectl. It is a tool. I don't know why they named it like that. Let me recheck.
No, actually, like we do same thing with the kubectl. So why we use the K9?
So you will see what's the difference between kubectl and K9S. So just install it.
I installed it.
Okay. So we have to create a kind cluster to interact. So just wait for some more time. So we just installed all the CLIs. Okay. Can we start then? All are ready?
Lavanya, actually, I have installed the kind, but I cannot be able to open. Even WSL also, I cannot be able to open.
Can you share?
Yeah, sure. See, it is there. When I click on open, it is not opening. It's just closing immediately.
Okay. So when did you enable the WSL?
Just now.
Okay. It needs a reboot.
Okay. Yeah, then let me try that.
Yes, it should work.
Yeah, thank you.
So could you help me with K9 install? It's in the Windows, right?
K9S, are you using a PowerShell or a WSL?
WSL.
Okay, so you can install it in WSL. I think the reference link I have given in the week 1. So maybe I will give you the exact instruction how to install it on WSL. Just a minute. Let me share my screen. So this is the K9S tool. So this is so for some of you asked why do we need K9S? So this is going to show you in UI. Instead you typing kubectl deployment kit, kubectl daemon sets or stateful set or services. Everything is going to be in UI. So it is going to be powerful while debugging it. So I want everyone to install it. So for WSL, this is the way to install. Yeah. Share it in the chat. But just open this link and then see which one you are using and then just install it. Okay, if you are using PowerShell, you can try Winget or Choco. Did anyone install K9S?
Yes, Lavanya.
Yes, Lavanya.
Okay. So using the curl command also you can install. I just pasted it in the last. Just run that in the WSL. It should work. It should install K9S.
Are these versions okay? I mean, like, are these kind of versions compatible with all of this?
So I think you might have installed the latest version. Yeah, I think it should be fine.
Okay.
Yeah, all good. I think this is fine.
Okay.
This should be enough to start. Yeah, I think you can figure out how to install the K9S. So let's start the lab. Already we are over time. So I think all the commands and tools that I have just shown you, it's from the week 1 GitHub link that I have shared. So it's in the README file. So you can install all the CLIs. So using that, if you are not able to figure it out now. So now we are going to create a local cluster to explore the master components. So I'm inside the week 1 folder. And then go inside Terraform folder. So we have not explored anything in the Terraform. So I just have a kind.yaml inside the Terraform folder. So that's why I'm asking you to navigate to Terraform folder under week 1. Okay. Yep. Okay. Everyone inside the Terraform folder?
Yes.
Let me share my screen. If it's not. I think my machine is shared. Do you see my machine? Yep.
Yes, we can see, but we can see readme.md file.
Okay. So let's see what we are going to do now. So we are going to create a kind cluster. So it is a local cluster. So which will have all your master and worker node components onto your local machine. So we are not going to create a difficult setup for now to explore. So we are going to create a simple kind cluster. So kind is one of the tool to install the local cluster onto your local machine. So another tool which is Minikube. Using Minikube also you can set up a local cluster. So we have another way called Kubedium, third way. So for which you need a different machines. So 2-3 machines you can combine together to create a master and worker node component. So for this lab we are going to explore the kind method of creating cluster. So that's why we installed the kind. So for some of you, if kind is not working somehow, you can figure out using the Minikube as well. So Minikube is also one of the tools to set up local cluster. Okay. So this is the sample kind cluster setup. So this is the so since we have installed the kind, so it is going to recognize the kind API, and then we are going to create a cluster. So we are going to create 2 nodes. One is control plane, another one is worker node. So control plane will have all the control plane pods like scheduler and API, etcd, and controller. So all the pods will be there, and worker node is for scheduling the applications. And then, so this is for now, we are going to use a different IP address for pod and for service. So this is a simple kind cluster. It's not a fancy complex setup. So just to start with, we are going to create a kind cluster with this command. So this is the command that I'm going to run. And then my cluster name will be, as you name it, you can create a kind cluster with any name. And then using the config, kind config. So I just navigated to Terraform. So do you see my terminal?
Nope.
No.
Okay. Let me reshare.
How we decide these IPs? Like this is a default, or like how we can decide the public IP?
So this IP, it has to, in the production level, production grade, this IP has to be decided. There should not be any clash with your network. Okay. So we are not going to create a kind cluster in a production grade. So for example, think you are creating a AKS cluster or EKS cluster. So you will have to define pod IP network. So for how big your cluster is. For example, if it is a small cluster, you can decide on which IP seeder. So mostly you will get it from your network team, or you will get it. So if it is a public cluster, you can create the IP from the portal, Azure or AWS or managed clusters portal. But if not, you have to figure out there should not be an IP clash from this pod networking in your network, and then decide on to this IP range. So this IP range, how big or small, it has to be based on your cluster size. For example, /16 is going to be a bigger size. Then, for example, if you need a smaller cluster, but you need multiple clusters, you will have to divide accordingly, /24 or /26. So you'll have to decide on how big the cluster size is, and then you will have to split accordingly. So how many number of nodes and pods it is going to be scheduled. So it's all based on the mathematical calculation, how much nodes require, how many pods are required to run on that node. So that we will come to it. Don't worry.
Okay.
Okay. Yeah, do it see my terminal or still
Yeah,
seeing some
Lavanya, sorry for interrupting. So when we talk about IP allocation, so are we going to cover CIDR calculation also?
CIDR calculation is not a difficult thing. So yes, we can cover that, and CIDR calculation and how we take the pod IPs and service IPs. So these pod IPs and service IPs should not clash. So yes, next session, so during the Kubernetes object discussion, I will cover that. Okay, so this is just to spin up a small cluster. That's it. It's good that you asked. Yeah, run that command, kind create cluster, my kind cluster. Then you will be able to spin up the cluster. So let me know if you see any errors.
So this calculation is similar to private subnet CIDR block and public subnet, right? The calculation of
Yes, IP calculation, IP the /16 /24 is just the same same networking concept. So so based on the /CIDR notation, the IPs will be segregated. So maybe I can pull up David C calculator and show you how much. So for pod CIDR, we are going to use this IP.
So as a platform engineer, do we need to understand in deep level, like how we can architecting that IPs?
Yes, you need to understand how big your cluster is. Because you are going to define this IP. For example, in my sample setup, I don't have any clash, so it is not my client network. So that's why I'm using the default pod subnet that I use. But I don't need this much host, 65,000 hosts. I don't need, right? I don't need this much big IP for a small cluster. So what we can do? So we will get the IP address from maybe from the networking team, or if you know from the whether you are creating a public IP, public Azure. So in Azure it will be an VNet, right? So during the VNet creation, you will get the CIDR. So this CIDR you should not be using a bigger CIDR. Okay. So maybe consider, for example, a medium-sized cluster. So you might need just 2000 for a medium-sized cluster, and then just pick up that /21 range for your cluster. Okay, but if you still need a further smaller cluster just for testing, you don't spend that much. So you don't spend 16,000 IP for a small cluster. So you should not be using bigger IP ranges there, right? And so you should not be using /18 or /20. So it has to be much smaller. So you can pick up /24 for some test clusters or non-prod clusters. So for prod cluster, it has to be picked up from a higher range, but this IP should not have conflict with your network. So for example, in my client network, I have this IP defined /23. Some other team is also using the same IP range for some Azure resources, Azure private resources. Okay, so they will have the same IP for Redis or some other resource. Then if there is a communication between these two services, there will be an IP conflict. So these IPs are decided at the customer level, and then you have to decide and then stick to that. So there should not be any conflict. So this is a pod CIDR that I have selected, and then so it doesn't need to be this much big, since it's not going to create any clash. I have went ahead with the default pod subnet and then created. But if you see the service CIDR, these two IP ranges should not be conflicting. These two should be completely different, because your pod is eventually going to be served from your service. So these two IP should not have a conflict. So ideally, it should be completely a different range. So if you see my service CIDR, you will see it's of a different range. I will show you where these IPs will be allocated. So it is also a bigger range, but ideally will not be choosing this much bigger range. /24 or /21 should be enough for a production grade cluster. And also it depends on the CNI, whether we are going to use the pod IPs from all your subnets. So that we will cover in the CNI session. But for now, I am just taking the default ones, whichever is there for the pod and service CIDR. So when this will be useful, so I am just spinning up the cluster. My cluster is spinned up. So basically what it does, it created a node, and then it created all the master components, and then it started the control plane and installed a CNI. So storage class is for creating any volumes. So for that, this has to be there. So this will also be created, and then it will have a worker node. For example, if I have to check whether my cluster is created, just go ahead and run this command, kubectl cluster info. So it will show you where your cluster is running. Okay. Did kind cluster get created for all of you?
Yes.
Yes.
Okay.
Still,
so now, okay, it should. Yeah. So let me run the first command, kubectl get pods. So just we are going to see all the pods that are created. We have not deployed anything until now. So these are the pods that are there. Okay. So by default, all the master pods will be scheduled inside the kube system namespace. So we'll discuss what is namespace. For now, understand namespace is an isolated environment to run a pod. Okay. So how to check how many namespaces are there? Kubectl is the CLI to interact with your API server, right? So we have created a cluster already. So first, I'm just running the kubectl get namespace command. So it showed me how many namespaces are there. So these are the default namespaces that comes along when you create a cluster. So which is kube system, kube public, kube node list, and default. Okay. So if you see all the pods, so to check all the pods, this is the command kubectl get pods across all namespace. Kubectl get pods -- all namespaces. So this will show all the pods across all namespaces. So let me pull that and then send it to you in the chat. So I want everyone to see what are all the pods that we have. So core DNS is for DNS resolution, and etcd is the one that we just spoke about. It's the database of storing all your configuration. So KindNet is a CNI here, and then Kube API server is your API server entry point of your master node, and controller that controls your there are different types of controllers. Basically controls your replica controllers. All these will be running inside the controller manager. And kube proxy for node to node communication. So you will see two kube proxies. Why? Because we have two nodes. So each and every node will have a kube proxy by mandate. Okay, so you have two nodes, and then these two proxies will be there for each and every node. So just run this O-wide command. kubectl get pods -- all namespaces -O-wide. I'm just pasting it in the chat. That's the command.
Lavanya, can we just do kubectl get node -O-wide once?
Yes.
Oh, but I'm not able to see it. I mean, it's stuck.
Is it? Okay.
Yeah. So here we can see the kernel version as Linux, no? So we haven't mentioned anywhere to take Linux machines for these nodes and how it picked up Linux.
Yes, we can define all the OS images, but by default, kind has all the default parameters. If we don't specify it, it gets picked up. And also we are installing onto your Linux machine, right? So it just picks up the default one that's there, and then it bootstrapped with that. And container runtime also, we didn't mention that it has to have container D, right? So it just picked up the default ones, and then it deployed using the container D. So, but what we mentioned, we just mentioned the name of the cluster and then what's the role. So two roles we mentioned. One is the control plane, and another one is the worker. So these two nodes we mentioned. So that's why we have two nodes. One is for the control plane, another one is for the worker. And for networking, we mentioned the IP address. I will show you where this IP address coming into picture. Get pods all namespace O-wide. So these are the pod IP address. So this /10.244.0.2. So all these are coming from where? It's coming from the pod subnet that we defined. So it's coming from here. 10.244.0.0/16. So these pod IPs are picked up from the pod subnet that we defined. And 172 is the node IP. So this is the node IP.
WSL is not visible.
Yes.
Yeah. And one doubt is, so in AWS or any other cloud level, VNet and VPC CADR ranges allocates or assigns IPs to us, no? The same way, so when we created the subnets here, so is it sharing our laptops DHCP to assign the pods to, IPs to the pods and nodes?
So basically, just this kind cluster, entirely this kind cluster is running from your Docker desktop. Okay. So it's not going to clash at your physical networking. So if I open my Docker desktop, you will see all these running as a separate container. So basically, so just open the Docker container, you will see these are running as a separate container. Okay.
Your screen is not visible.
Yes, sir.
Can someone share the Docker desktop?
Sure. Where is here?
Can anyone share the Docker desktop screen? Then you will see the containers that are running and nodes that are running as all as a container. So what's your machine name?
Mac.
No, your kind cluster name?
1 second. Actually, I simply installed the kind.
Okay. kubectl get nodes. Just run the kubectl get nodes. So your cluster name is my kind cluster. Okay. So this will be running in the Docker desktop. But to answer your question, so this is not sharing any DHCP IPs. So it's basically a single Docker container that is running onto your Docker desktop. Okay. So my kind cluster, just search. So it has two containers running, one for control plane, one for worker node. So basically we are running inside the container. So this is not interacting with your physical machine, because our physical machine will have a single IP address, but we need to as many machines as we want, right? So it is not going to interact with your physical machine. So no DHCP involved.
Okay. So unlike VMs, it is not okay. It is running as containers.
It's running as a Docker container. So primarily it runs on a Docker desktop on a local machine. So there is no DHCP or DNS resolution that's creating a problem here. Okay.
Okay.
Okay. Thank you. Thank you for sharing your mission. Yeah.
And
Okay.
what
So
is the service subnet? Like I understand the pod subnet, so like pod have that IP. And what is the service subnet? Like where it is the IP?
yes. So you just ran the kubectl get pods all namespace wide command, right?
Yeah.
Same like that, run the kubectl get service -- all namespace wide. So you will see the service IPs. So for now we have only two IPs, two services that are created as part of our kind cluster. Okay. So these two are the services, and this IP, if you see 10.96, it is coming from the service subnet that we defined. Is my screen visible?
Oh yeah.
Okay. So this is coming from the service IP. The first command that we run is for the pods. You will get the IP from this pod subnet that we defined. Okay. So that's the difference. So you should not have a clash between these two. So anyways, it is not going to. Hello? Is my terminal still visible?
Yes, yes.
Okay. So that's where your service IP that is coming into picture. So now what I'm going to do, so we have seen all the master components. So I'm going to connect inside one of the Docker container. So run the Docker exec again from the same lab README file. Just get inside the control plane. So I want someone else to share. Let's debug it from your machine. Since I see some of you are saying that my machine is not visible. So any one of you comfortable, just share your machine.
Do I need to share?
Yeah, you can share, Kianshu. That would be much helpful. So run the Docker exec. It's there in the README also. Control plane, yeah. Bash. Yep. So now list etc Kubernetes manifest. So now observe all so these are the master components that are created. So these are the pods that will be created in the control plane. Okay, just open any of this folder. So this is, yeah, just cat this file, yes, etc.yaml.
One second.
You can cd inside it, yes. So this is your etcd configuration. So if you see the kind, it is a pod. Why it is a pod? So I was telling about a lot of terminologies like deployment, stateful set. So all these are for the applications that are running inside worker node. But master pods will always be specified as static pods, and it is coming from this location onto the control plane. So etc Kubernetes manifest is the folder that has all the static pods of the master. So no, this is one of the important questions that some might ask in the interview. So just note it down, like this is the folder that we have static pod etc Kubernetes manifest, and this is the configuration for etcd. So here we will mention all the etcd configurations, like what is the certificates that are used, and then what is the backup location. Everything will be configured from here in this etcd configuration. Okay, what is your cluster name, what is your etcd, and how many replicas of your etcds are there. So for now we have only one, since it is a kind cluster. Come down. Yeah, so peer authentications. So these probes, request, everything, we'll see it in the upcoming classes. But this is the configuration for etcd, and same like this, you have a configuration for controller. Yeah, just to go and open the other file.
API server.
Yeah. You can go up. So here what we'll do, we will configure, this is also a static pod, and then it has all the configuration for Kube API server. And then if you see from the diagram that I showed, it has to have details about etcd, right? It has to connect to the, this is API server is the only component that gets connected to the etcd. So this API server should have a separate section. If you see under the commands, you will see the etcd configuration. So where is the etcd configuration, and what is the etcd server? Yeah. So etcd configuration will be here. So for everything you need a certificate to communicate. So it should have a CA cert, client cert, and client key. So all these has to be passed so that it can talk to the etcd server. So in our case, we had only one etcd server. So if it has 2 or 3, then all such etcd configuration should be mentioned here in the API server. So then only it can communicate. So in terms of high availability setup, you need to have 2 or 3 etcd configurations. Yeah, and also have multiple API server configured just to avoid any outage. So come down. Yeah. So these are all the probes and configs. So now just what you do, can you do MV and let's stop the kube scheduler, kube-scheduler /tmp. Yeah, enter. So we don't have a kube scheduler running now, right? So now just to create another, open another WSL terminal now. Okay. So kubectl get pods -all namespace. Just -capital A. That should be enough.
Okay.
That's a alias. Shortcut. You can enter KGP or kubectl get pods. All are same. So if you see, we don't have a scheduler running, right? So it's gone.
Yeah, so still it is running, right? Cluster is running.
Still your application is running. So what you do now, go to the README Again,
Okay.
go to the README, go down. Okay, so go up, kubectl create deployment command is there. Just here, yeah. Run this. So now what we are doing, we are creating a new deployment when scheduler is down. Now run the kubectl get pods.
Pending.
So what is happening? It will be pending. It will be pending for a long time until your kube scheduler is up. But still your application is up, right? So your other applications are up. So now you do one thing. You move back the kube scheduler again.
Okay.
mv/tmp kube scheduler kube, and then yeah, just slash yes. So now kubectl get pods. All, yeah. So it will be creating now. Why? Because we have the scheduler running. Okay.
So I have one question. Like if we remove the scheduler, so where all of these existing pods are running?
So what is the main work of scheduler? So if there is a new pod that's coming, it goes and schedules onto the right node, right? If scheduler is down, if a new pod comes in, it will not have an instruction to schedule on to which node, so it will go on pending. So that's what we have seen. But existing pods are already scheduled, right? Already scheduled on to the worker node. That is not going to affect because Kube API server has the detail like this worker node has these pods scheduled. So it is not going to kill all of the existing pods. But what you can do, if you delete the existing pods, then your application will go down. So as long as you don't delete, it will still survive for some time. So if you delete the pods, then it's gone. Your application will be down. All your existing application will be gone as well. So as long as it is rebooted, you are safe. But there is no guarantee that it will not be killed, right? Due to if there are loads, there might be the pod gets restarted. So in that case, restart will also go in pending. If you delete the pod manually, if you see now, then also it will not work. So now, Priyanshu, you can go back and then again move. Let's investigate that. Previous command. Move to temp.
Okay.
Yep. Now go to the terminal again. Yeah. So check the pod. Delete the Nginx pod. Kubectl delete pod. Hyphen namespace hyphen n. Yeah, that's an alias. Kubectl delete pod.
Okay.
Hyphen n. Default. I think you should type default after namespace. Okay.
Okay.
So -n is the alias for namespace. Okay. So you can use -n as well. So delete pod and you have to give the Nginx. Yeah. So now you deleted the pod. So now check. Pending, right?
Yeah.
It will be pending until your scheduler is back up. So if you delete all the pods, etcd, API server, yeah, that's it, gone. Cluster will be in down state. So now go back. Yeah.
So if the scheduler is down, so it will not completely delete the Nginx deployment?
It will not, because the details are there in etcd. You're not deleting etcd, right?
Yeah.
So configuration is still there.
Okay.
Just that it cannot schedule.
So it will always in the pending state.
Always, yes. After, yeah. Until kube scheduler is up, it will be in pending. So by the time your API server and etcd gets restarted, your cluster will be down. So until that time, it can survive.
But what are the reasons that a scheduler will go in like?
So for example, you have a 3 master nodes. So for now, we have only one control plane, right? That control plane is hosting all the master components. So if that control plane is down, okay, then your scheduler that's running on that node is also down. So in that case, scheduler will go wrong. But also if you do any misconfiguration in your scheduler, so we have seen the pod already, right? So if you do an incorrect certificate mapping, if you do some incorrect configuration, like mapping a wrong IP, wrong port, and then wrong certificate. So all these are some of the contribution of the scheduler that's not getting up. Not only node goes down, but a misconfiguration there. So you are passing a location where there is no certificate. So then it will not find the certificate to communicate, right? So then in that case, it is a misconfiguration and it is not going to be up. So that are some scenarios where the scheduler component might be down. And Priyanshu, you can go back and then move the file to the right location. So let's bring up the scheduler. I think it's overtime, so let's finish up in some time. Yeah. So now you have the scheduler. Scheduler is up and running. Do the same. Do the same for controller manager.
Okay. Yeah, it moved.
So there is no controller. Now you do one thing. Kubectl space scale deployment deploy. Just type as deploy. That should be enough.
Okay.
Namespace default -n default nginx space nginx. Yeah, nginx deployment. Just hit tab. It should hit tab.
It requires
nginx. Okay, there's no less. Okay, fine. Hyphen. No, nginx deployment. That's your deployment name. Nginx hyphen deployment. So next class, what we can do, you can add auto completion for kubectl. Just check auto completion and then enable it so that you don't have to type entire thing every single time. Okay.
Okay.
Now hyphen replicas. So now what we are doing, we are scaling the replicas from 1 to 2. Yeah. So now you scaled. Can you check the pod count? Still not scaled. Will not be scaled. Why? Because the controller is down. So the replica controller will not work. So just move back the same file. It should be up in some time.
Okay.
Controller is up. So it will take some time.
Lavanya, these are the default pods running, right? We have not deployed any custom pod, like we have not deployed custom application, right?
No, we have not deployed any application yet. We just deployed a sample nginx application. So he did the kubectl create deployment nginx. So we have created a new deployment using kubectl command with nginx image just to test this component. So what will be the impact of a master component that's not running? Okay. We have not deployed any custom Elm chart or custom Elm application, but a simple Nginx application. Okay.
Okay. And as you said that like there will be reasons that scheduler will go in down status, but as of now, initially you have not done such a thing like certificate management that you said. It is by default managed by the Kubernetes itself from the backend, right?
Yes. So if you have the managed Kubernetes, all the certificates, everything will be managed by you. But if you are managing a self-managed, you will manage all the certificate things and the certificate location. You will put all the CA certs and CA keys, everything, cert key and cert term, everything. You will put that in the right place to before you spin up the cluster. So it cannot go down by itself. If you do if someone is changing the location for some reconfiguration, in that case it might go down. So by default, that's not the day-to-day operation. So making the scheduler down, or it's all if someone does a misconfiguration or the node goes down for some reason. So those are one of the scenarios, but to handle that, we will have multiple replicas for those multiple instances of those critical components. So multiple VMs will be serving. For example, for controller, you will have, for example, in master, you have 3 master nodes, 1, 2, 3. In one master node, you will have API, another master node, you will have etcd, or another master node, you will have controller. But still, it is one instances. If that particular node goes down, that component will be down. But if you have two components in each of these nodes, for example, you have etcd in one, another one is also having an etcd, you will have at least covered some of the high availability, right?
Okay.
So in that case, it can withstand the outages. So you'll have to configure at least 3 replicas for each of these master components. Then it should survive. So ideally, in Kubernetes world, it is always 1, 3, 5 to avoid split brain. So split brain means if 2 is there, then there might be chances that there will be a problem in election. Who is the master? Who is just a replica of it? So it is always hard. It is always a good practice to mention 1, 3, 5 as number of instances instead of 2, 4, 6. Okay. So basically, whenever there is a master election component that's coming, so you will have 1, 3, 5. So this is mainly for master component. So for worker nodes, you can scale to 2 replica, 3 replica, 4. That's not a problem. But wherever this election coming into picture, so it's better to have 1, 3, 5. Odd number.
So how the election is made, like is there any policies we wrote?
So basically, we can control the algorithms as well. So it will check in round robin fashion by default. So which node is up? For example, if the master node 1 is down, then we have another master node that's serving, right? So that will become a master. So basically, the election will be done by these 3, for example, by these 3 pods. Like it constantly, you will check in the logs. If you see the logs, you will see who is the master. But for now, we have only 1 replica of it. So when we schedule 2, then we'll see who is the master. That we will see it in the later, maybe. Yeah.
Okay.
Okay, now you can make the API server down and then watch.
Not working anything.
Not working. So it's down, right?
Yeah.
Not do anything. Same with etcd. Just move back the file. Until then, it will not work. So you know the critical component. It will take some time. It's not going to be immediate. Yeah, it will run now. Yes.
Yeah.
Same with etcd.
Yeah, Lavanya. Meanwhile, so controller manager is basically always checks for like controllers. We have something like deployments and also replica set. So it always ensures if something replica set is set to 5, it always ensures to run 5 pods. So controller manager is responsible for that.
Yes. So not only the replicas, for the nodes as well. So there's a different types of controllers. So it cannot scale up, scale down nodes as well. So because node controller is also down, right? So we don't have separate controller configuration. It's all clubbed into a single component called controller. Controller is down, none of the controller is going to work.
Okay.
So one such type is the replica controller that we saw.
Yeah, so almost like all Kubernetes object controllers, we have a lot of other controllers as well, no? Like
Yes.
volumes and all. Okay.
Actually, yeah, we can discuss that. So we have different types of controller: node controller for node management, and replica controller for replicas, deployment controller for managing the deployments, and replica set for replica set, and job controller for creating the Kubernetes job. And also you have endpoint controller to check if the endpoints are up to serve any service to pods. Namespace to ensure you can create new namespaces. So those are the namespace controllers. We also have custom controllers apart from these. For example, if you create any Argo CD, you will have an Argo CD controller. Any other tools like Nginx, it will have an Nginx controller. So every such component is a controller.
Yeah. So are we going to discuss CRDs also going forward?
We can discuss the CRDs. I will show you how a CRD will look like. So we can also create a custom CRDs, but we don't have to write a big CRD. So if you deploy any tool, it is going to be another CRD that will get deployed, right? So yeah, we will see that custom CRDs, how to create a custom controller, custom operator. So Argo CD, everything is a add-on operator on top of it. It is going to create a CRD onto your Kubernetes cluster.
Yeah.
And are we also focused on the run C and the like crun and PRIO?
So I think one should be enough, right? So it's all going to be the same container runtime. So we are not
You mean
going
like
to
the container D? Are we using
Yes.
container D? Okay.
So now in the kind cluster, it has spinned up the container D runtime. So underlying pieces will be the same. So it's basically used for creating the containers. So it doesn't matter if we use run C or container D or CREO or whatever. Okay.
So if as a DevOps or the platform or the SRE engineer to troubleshooting some issues, so do we need to deep down into the container D level?
Ideally, no. We don't have to deep dive inside the container D. So all you need to check is whether your kubelet is running, kubeproxy is running. Maximum what you can do, you can just log in to your node and check your container D configuration and pods. But anyways, that is not going to be the because it's all the nodes will have similar configuration. If a node is down, then all these pieces will be down. You don't have to debug inside the container D what is it. So just that you can check the logs. That's it. You cannot do more on it.
Okay.
So we are not going to look at all these tools. So one should be enough. So we have used container D already. So basically it's just to spin up the container. So we don't have to debug much into it. All that we see is log into the node and just check the journalctl pods and see what is the problem with the container D. Otherwise, yeah, I have not done, in many instances, I have not even debugged into the container D level because it is inbuilt for you. You don't have to debug more. Just you have to select which container D has to be running. So nothing more. So that's not going to be your real-time troubleshooting. So basically the troubleshooting that comes in will be on the tools that are running onto your cluster and cluster upgrades, cluster managements. So those will be your main troubleshooting areas.
Okay.
Okay.
Yes, and as we are talking about container runtime, so in production systems and in companies, so this Docker is not being used for security reasons, right? Now. So to
Yes, Docker
debug a
is
node,
in
I mean,
general,
to
in
debug a
production,
node, like what kind of something like Podman, or we are using Podman. So what's the ideal way?
so basically what you do, you just log into the node, right? So now you have used Docker exec to log into the node container, right? Similarly, what you will do, you will log in inside the node, right? And then though Docker is not a container runtime, Docker command will still pull the image, like still pull the, so the Docker inspect, Docker logs, everything will work in even inside it. But what you need to do, so for container D, there is a separate tool that will be there to debug. So it will be a container, I think the CLI is container D. You have to connect inside the node and then run the container D to inspect the logs on of that container. That's it. That much you can do.
Okay, so the container runtime is only for, I mean, the container D or whatever. It is for applications, you mean?
Basically for troubleshooting the containers. That's it, not for the masters and all.
Okay.
So basically you will SSH into the Kubernetes node, and then if you will install the tools. So it's not necessarily Docker. You can install CTR, CRI-CTL. CRI-CTL is one of the widely used tool. CRI-CTL.
CTL, yeah.
CRI-CTL, CTR. So these are preferred. So just you can check any tool, and then you can just for interacting with the containers, you can install them and then run the commandlets. So CRI-CTL, PS is going to list down. So similarly, you just run that commands, right? For similar to Docker, you will use the CRI-CTL to connect inside your node and then run and inspect the container issues.
Okay.
So you will inspect the container, you will inspect the log, you will pull the image manually to see if it's really pulling the any external images, if there are any blockers accessing those images from different container registry. Yeah, such things you can do it using the CRI-CTL or CTR. So there are different tools available, but yeah, based on the container runtime that you install it in your cluster, you can use similar commands and then debug it.
Okay.
So just to recap what we did, we just understood what is the Kubernetes architecture at the high level, and then we created a sample kind cluster, and then we discussed something about the pod subnet and service subnets, service CIDRs that we configured, and then we pulled a sample deployment, Nginx deployment, and we observed the behavior when one component is down, what will be the impact of it. And then, yeah, and we did not configure too much onto the kind cluster. So we just went ahead with the default ones. So which did container D as a default runtime, and it pulled the Linux as our in-base image for those master and worker nodes. So yeah, so we are going to continue using this kind cluster. So what you can do, you can delete it. So for every new session, you can create a new kind cluster and then install those tools whichever is required. Otherwise, it is going to consume your memory and resources. So after every session, you can either delete it or yeah, you can keep it as it is and then reuse it for next time as well, as you like. And in the next class, I want everyone to have auto completion for kubectl. So just check auto completion for kubectl and then install it. And we'll see how we can use K9S tool. K9S is one of the other CLI tool that is used to interact with your API server, Kube API server. Yeah. And then we will debug more on kube configs, what's kube config, and then we'll work on Helm in the next session and basic Kubernetes objects. So that is our next agenda. And then we haven't even started the Terraform, which I wanted to start. Maybe we'll resume it in the next class. Okay.
Ma'am, can you share some troubleshooting tasks with us? Like today we read about the architecture, right? Like EATS architecture. So what kind of interview questions like interviewer can ask to us?
Okay, so I will also give you the tasks. Just give me some time. Let me see what project we can assign for today, and then maybe in the next session you can do a demo, just a small 5 minutes demo to see how you have done. Okay.
Okay.
So I want you to do a simulation on image failures and debug how, I think there were questions about container investigations, right? I want you to do that. So maybe I'll give 2-3 tasks and then you can figure it out, see how it goes. No, does it need to be a demo? But yeah, just to explain how have you done that.
Okay.
Okay. So the mock interview question, let's see if we can cover in the next session. We don't have much today. So since it's just the architecture, so already you know what will be the impact of what not running, right? So those you can brush up and then install all tools. So you can also do one more thing. There is something called EZSH. So now we are using plain WSL, right? Installed EZSH as well. And then Power 10K. So explore these two. Power 10K is an add-on in ZSH. So you will feel good about using ZSH ZSH terminal instead of WSL. So maybe we can discuss more in the next class. Okay. But if you can check, go ahead and check it.
Thank you.
Also try Lens. Yeah, try Lens. There is another tool called Lens, which is also very good. Install it and then let's explore it in the next session. I think we are almost over time. Should have completed an hour back at least, but it was too much for today. Yeah, but thank you. It was quite interactive and I see a lot of questions, valid questions. Yeah, which is very good. Thank you, team. And yeah, let's keep up the same for the next class as well.
Thank you, ma'am. Thank you so much for your time. Thank you. Thanks, guys. Bye-bye. Take care.
Thank you.
Thank you.